All right, the recording has started, so here we go. Hello, everyone. This is Rebecca Dallin, Assistant Superintendent for Stormwater Quality here at the City of Oklahoma City. I'd like to officially welcome everyone to the second installment of our 2023 bi-monthly webinar series. We will begin the main presentation momentarily, so I want to provide some information to help enhance everyone's experience during today's program. In order to reduce background noise, we ask that everyone keep themselves muted during the presentation. If anyone has any questions during the presentation or at any time, please feel free to type them into chat. I will be monitoring chat for questions and we'll answer them or have our speakers answer as many questions as we have time for today. If anyone has, if anyone would like to receive a certificate of attendance for today's webinar, please send me an email to request it, and I will put my email address into chat so you'll have it handy. Each of the presentations in this webinar series will be available within a week or so after the scheduled webinar date on our website. It'll be under Stormwater Workshops. And the section where these are going to be posted will be, of course, called the 2023 webinar series, and today's session will be the April edition. I will post a direct link to that later in today's program. The 2022 series will only be on our website a little bit longer. We've removed several of the presentations already. I think we're going to just kind of phase them out as we add new ones this year. But those videos are on YouTube. So if anyone needs a copy of those links for reference, please email me. I'll be happy to send them to you. If anyone has any questions at this time, please feel free to type them into chat. But without further ado, I will play the very short welcome series presentation.
Good afternoon and welcome to our bi-monthly Stormwater Quality webinar series. We always enjoy providing opportunities for everyone to learn how to help keep our local waterways clean. Remember, we're all downstream from someone else, so we all need to work together to protect our waterways. This year's series has several great presentations planned. You will have the opportunity to hear from some of our own stormwater quality staff as well as select guest speakers. We hope to see you for each session, so be sure to tune in. As we've briefly mentioned, each of the presentations should be available online within a week or so after the presentation is aired live. It will be posted on the workshop section of our Stormwater Quality website. We'll put a direct link to that page into chat toward the end of today's program. If you haven't signed up already, please do so now by pointing your phone's camera at the QR code for the newsletter or newsletters that you're interested in. The only way to sign up for either the construction or industrial training and education newsletters is via a direct website link or these QR codes. These options are both hidden in the email service site, GovDelivery. These two newsletters are the main way that we announce upcoming training, webinars, and workshops, so be sure to sign up. The quarterly newsletter is the third QR code, and it provides overall information about what we're up to. You can find this one on the GovDelivery website or use the QR code today. If you miss any of these codes, be sure to send Rebecca an email and she'll send you the direct website links. We also have an excellent Lunch and Learn series planned for this year, and the registration announcements will be sent through these newsletters. Some of our presentations will be live and some will be pre-recorded. We do our best to provide as much detailed, accurate information as possible while also working with the presenter's strengths and their schedule. We live and work in a beautiful community here in Oklahoma City. For more information about stormwater, what we're up to, and local regulations, be sure to visit our website.
All right, up next is the main presentation for today's webinar. And we're going to hear from two guest speakers from our own construction inspections work group, Melanie Lawson and Jairus Greco. Melanie has been with the City of Oklahoma City since early 2021 as an environmental technician in the construction section of the Stormwater Quality Division of Public Works. Prior to service with the City of Oklahoma City, Melanie worked as an air and stormwater quality specialist in the consulting industry and an air quality program coordinator with the Choctaw Nation of Oklahoma. Melanie graduated from the University of Oklahoma's College of Atmospheric and Geographic Sciences in 2014 with a bachelor's degree in environmental sustainability with a science and natural resources focus, and currently serves on the board of advisors for the College of Atmospheric and Geographic Sciences. And of course, we have to add Boomer Sooner. Jairus graduated from the University of Science and Arts of Oklahoma, USAO, with a Bachelor of Science in Natural Science. He gained experience in the Oklahoma and Texas oil fields as a field chemist before taking a position at the City of Oklahoma City's Hefner Water Treatment Plant in 2020, and then transferring to stormwater quality as a construction inspector in late 2021. So these folks have been with us long enough to know the ropes, and so they're going to be sharing a lot of their expertise with you today. Go ahead, Melanie.
Can you see the screen?
Yes. Whenever you're ready. Hey, we can't hear it and we're seeing other things. Did you remember to toggle on that include computer sound? Sorry, I was going to remind you already and I didn't. I apologize.
Can you see the screen?
Yes, just don't click away from it because we did see other things when you clicked away.
Okay.
Hey everybody, welcome to the webinar. My name is Jairus and I'll be walking you through the first half of today's presentation. Oklahoma City Public Works Stormwater Quality thanks you for taking time to attend today's presentation. It's our goal to keep our land and waters as free of pollutants as possible during the construction process. This can be accomplished by performing high-quality site inspections, implementing and maintaining stormwater controls, and keeping accurate records of your inspections. Doing so can greatly reduce the quantity and potential release of pollutants from your job site. We have 4 sections of discussion for today's webinar, which will include employee training, contractor certification, site inspection reports, and corrective actions. In the following slides, we'll discuss the importance of getting your field personnel trained on how to use the Stormwater Pollution Prevention Plan, also known as the SWP3 or the SWIP. Knowing how to use the SWIP while inspecting your site can help you make the best choices on how to implement and maintain stormwater controls, and what information is pertinent to add to your site inspection report. Employee training. Before you begin earth moving operations, you should have an idea of who will have SWIP responsibilities. These individuals must be trained in the following SWIP requirements. 1. The proper design, installation, and maintenance of site-specific stormwater controls. Not all job sites require the same layout or type of stormwater controls. While there could be overlap between projects, it's imperative that the job site reflects the stormwater controls that have been approved in the SWIP. 2. Adequate storage of all chemicals on site, such as gasoline, diesel, hydraulic fluids, greases, or other potentially toxic and reactive substances. In my experience, this is a commonly overlooked pollution vector, especially on large projects. Pay special attention to what chemicals you have on site and appropriately label them, store, and dispose of these products to ensure they do not contaminate the environment. 3. Proper inspection of the job site and its stormwater controls. You'll hear this often today, The rule of thumb when it comes to proper site inspections is, if it's not written down, then it didn't happen. Take notes during your site inspection and write down any deficiencies found. Conducting site inspections will become easier the more experience you get in performing them, but at a minimum, all personnel should be trained to know the following. 1. The location of all stormwater controls and how to properly maintain them to good working order. 2. Pollution prevention requirements that are outlined in the SWIP. 3. Adhering to the correct frequency of site inspections as outlined in the SWIP. Lastly, it's important to keep a record of your team's training by filling out a SWIP training report. This will include any staff or subcontractors that have SWIP responsibilities. In the next slide, we'll go over an accurately completed training form. This is what your SWIP employee training report should look like. Take time to fill out each blank accurately and legibly, because when it's audit time, if it wasn't written down, then it never happened. In this example, we have Big Project Phase 3 with the appropriate OKR 10 number and the instructor's name with his or her title. List where you're conducting your training, whether it be at your training center, a tailgate meeting, or on a Teams meeting. List the date, approximate course length, and indicate what aspects of the SWIP you'll be training on. Our example lists training as a SWIP overview, which can encompass the following categories: sediment and erosion control maintenance, spill prevention, stabilization practices, housekeeping, inspections and corrective actions, and emergency procedures. Next, let's discuss contractor certification. In the next couple of slides, we'll talk about the contractor certification form and how it's used to ensure that all parties outside of the permit holder will be responsible to adhere to the SWIP. The contractor certification forms aren't a permit requirement, but can be helpful to you in the management of your job site and SWIP requirements. These certifications are initiated only by the permit holder and with the cooperation and agreement of the contractor. These certifications are used for contractors that don't have their own permit and are working under yours. These certifications are used to ensure that all parties performing construction duties on site are adhering to and familiar with the Notice of Intent, SWIP, Better Management Practices, aka BMPs, and other control measures. If used, the permit holder must ensure that all contractors in the plan are identified as being responsible for implementing stormwater controls and sign a copy of the contractor certification form before performing any work in that area. All contractor certification forms must be included in your SWIP and must include the name and title of the signatory, site address, and date of the certification. Here's the contractor certification form. Like all forms in the SWIP, this has the potential to be audited by your stormwater inspector. Therefore, it's important to have all contractor certification forms filled out completely, accurately, and legibly. These forms must also accurately reflect the current roster of contractors that are working on your project, with up-to-date contact information for all parties involved. If you're going to have multiple contractor certifications, please feel free to use additional forms if you need more room. Now that we've gotten through employee training and contractor certifications, let's get into completing a site inspection report. Performing regular site inspections comprises not only inspecting your job site to ensure permit and SWIP compliance, but also checking all job-specific documentation and ensuring that it's up to date with the current site conditions. Doing so will help mitigate and correct any potential flaws in the stormwater controls, the job site itself, and your documents. The inspection report is designed to be customized according to the BMPs and conditions at your site. To make your site inspection easier, you should bring a copy of your site plan and number all the stormwater BMPs and areas of your site that will be inspected. A brief description of the BMP or area should then be listed in the site-specific section of the inspection report. For example, specific structural BMPs such as construction site entrances, sediment ponds, or specific areas with silt fence should be numbered and listed. You should also list non-structural BMP areas that will be inspected, such as trash areas, material storage, temporary sanitary stations, etc. We'll have an example of this in step 1 of completing your site inspection report. Inspection frequency and record keeping. Your site should be inspected every 7 days if it's located in an aquatic resource of concern, in the Lake Thunderbird watershed, if it will discharge into an impaired body, or is 40 acres or larger. Otherwise, your site can be inspected every 14 days. The site must be inspected within 24 hours of a storm event that produces half an inch or greater precipitation. Please note that this storm event does not take the place of your regularly scheduled site inspection, but will be supplemental to it. Document your inspection and any corrective actions taken. Remember, if it wasn't written down, then it didn't happen. Regulatory inspectors will periodically request a site inspection and post-storm event reports for review. The links at the bottom of the slide go directly to the OKR 10 inspection report form and the site inspection report template for your convenience. Step 1. Completing a site inspection report. When filling out the first step of your site inspection report, please ensure that each blank is filled in correctly and legibly. This is the information that you'll need for the general information. You'll need the project name, inspector name and information, inspection frequency, the current weather information, and discharge information. Now let's see how that fits into the form. Always starting at the top of the form and working your way down will ensure that no blank is missed. The inspection date should always be the date that the inspection was performed. Site inspections can rapidly change, so it's important to keep consistency throughout the inspection process. Record the complete project name. This is especially important if you have multiple phases of the same project going on at the same time. The person performing the inspection should list his or her name, phone number, and email address. The email address is especially important in terms of communication because all Oklahoma City stormwater inspectors will be emailing reports and photos of your site directly to your stormwater inspector. If there happens to be a storm event, be sure to accurately record the rainfall volume and then empty the rain gauge afterwards so that future recordings don't have a positive bias in them. General information, key points. Here are some key points to take away from the information thus far. Your site inspections should be conducted in accordance with one of the 2 schedules listed below. At least once every 7 calendar days for high priority, TMDL, or aquatic resources of concern, or at least once every 14 calendar days. Regardless of which inspection frequency you choose to schedule, an additional stormwater inspection must be performed if a storm event produces half an inch or more precipitation. The permit holder must specify which inspection schedule he or she will implement in the SWIP. Remember, Post-rain event storm reports are in addition to the routine inspection reports, and always complete all data fields and write legibly. Step 2. Completing a site inspection report. Stabilization of exposed soil. List the areas where soil stabilization is required to begin because construction work in that area has permanently or temporarily stopped. Non-disturbance greater than 14 days or 7 days of TMDL, high priority, or ARC areas. Also record all areas where stabilization has been implemented. Soil stabilization is extremely important to be done in a timely manner, as the potential to release large amounts of sediment into the streets, storm drains, and neighboring properties is extremely high, especially with unvegetated slopes. Vegetation is the absolute best sediment discharge prevention tool at your disposal. It's highly recommended when starting the initial grading process to leave as much natural vegetation as possible. The more rooted vegetation you have, the less sediment discharge you'll have. These releases may not seem like much at first, but over time they can drastically change the topography of your job site, negatively change the chemistry in water bodies, affect local wildlife, pose challenges to local water treatments, and severely damage the environment. Out of all the potential pollutants during a construction job, sediment is the #1 pollutant. This is the form you'll use to record stabilization. For each area where stabilization has been initiated, describe the progress that has been made and what additional actions are necessary to complete stabilization. Record your stabilization dates of when stabilization will begin, when additional stabilization will occur, and when final stabilization has been achieved. Here, we see that the pond banks have been stabilized with sod on the north and south sides. Common Area C will be seeded, but won't be started until a later date due to delivery scheduling. When major construction activities are complete on a part of the job site and final stabilization for that portion has been documented and completed, inspection frequency may be reduced to monthly in the stabilized area. Permit holders can amend or add to this section as the areas of the project are finally stabilized. Your site plan should be updated regularly to indicate these changes. Once you're finished with a project and ready to file for a notice of termination, you must have all bare areas stabilized to 70% uniform coverage of the native background, and all stormwater discharge from construction activity must be eliminated. Stabilization examples. In the following photos, you can see some temporary and permanent stabilization measures being used. An important note is that all stabilization measures will require regular maintenance until vegetation has been completely established and is root bound. In this first photo, the permit holder has an elevated area of disturbance which has a high potential to pollute. His selection of erosion matting and reinforced silt fencing has been doing a great job at collecting any sediment discharge from his job site. The combination of erosion mats, reinforced silt fencing, and vegetative buffer at the curb, and regular maintenance has made this job site easy for their inspectors and ours. I chose this second photo to show just how essential properly implemented and maintained stabilization and controls are on your projects. We had a huge rainfall event which discharged massive amounts of sediment and rock off the job site and into the neighboring apartment complex. Thankfully, the permit holder kept the slopes vegetated and then installed reinforced silt fencing to trap any potential release. This made the cleanup process much easier, much cheaper, and faster. This is a photo from a relatively flat job site that had properly sodded roadways, but they also installed some additional temporary stabilizing mats. It's been doing a great job at keeping most of the sediment off the job site, on the job site, and off the streets. Here we see a bare slope on the right and a properly stabilized slope on the left of this drainage flume. Leave your BMPs in place until all your areas are properly stabilized. These two photos are of the same drainage flume. The first one was taken in February 2022, and the second one was taken in May 2022. It only took 3 months for this entire flume to wash out on either side. Initially, the flume was stabilized on either side with sod, but the operator failed to stabilize the rest of the sloped area, which caused massive undercutting and extreme erosion. Now, this entire area will have to be regraded, resodded, and permanently stabilized. The erosion was so high that it eventually exposed a gravity sewer line near the bottom of the flume. And here's one more photo of the apartment complex just to show how much dirt washed off of that project. Stabilization methods and BMP importance. Key points. Here are some key points to take away thus far. 1. Be aware of your limits of disturbance. All bare areas that have been graded or disturbed during the project will require vegetative stabilization regardless of property lines or limits of disturbance indicated on the project plans. 2. Implementation and maintenance of controls is required until final stabilization. 3. If seeding, vegetation will have to be established and reach a 70% density. 4. When stabilizing, focus on sloped areas first, as this is a major contributor to soil discharge. Again, Oklahoma City stormwater will require all disturbed areas, regardless of property lines or limits of disturbance, to be permanently stabilized if it was disturbed during the construction process. Also, if your job site has been stabilized properly and then utilities are installed, it's still the permit holder's responsibility to have those areas stabilized. These will be considered support construction activities for your job site and therefore part of the construction process. So schedule and speak with your contractors regularly. This is where contractor certifications can come in handy. All right, guys, thanks for listening to my portion of the webinar. I really appreciate everybody coming out and taking time for this. And now I'm going to hand this off to Melanie. Thanks.
Jairus. Now let's move on to step 3 of the site inspection report. In this section of the report, you'll provide a list and description of all structural and non-structural BMPs that are indicated in the SWIP. You'll identify the location of each control, and during inspection identify whether the controls are installed and operating properly, or if any corrective action is necessary. You'll provide the date in which the identified condition triggered the need for any maintenance or corrective actions, and in the notes section, describe the specifics about the problem. For this step, you want to take your site erosion control plan and update as needed, depending on what is observed on site. Let's discuss the differences in structural and non-structural controls. Non-structural BMPs or controls are typically passive or programmatic and tend to be a source control or pollution prevention BMP that reduce pollution in runoff by reducing the opportunity for stormwater runoff to be exposed to the pollutants in the first place. In many circumstances, it may be easier and less costly to prevent the pollutants from entering the drainage system rather than to control them at the end of the pipe. When used properly, non-structural BMPs can be very effective in controlling pollutants and will greatly reduce the need for structural BMPs. In addition, non-structural BMPs tend to be less costly, easier to design and implement. Typically, the measures do not require maintenance, but do require administrative resource commitments to ensure that they are continually implemented. Non-structural BMPs normally do not have technical or engineering designs associated with them. Here are some examples of non-structural BMPs. Public education and participation, land use planning and management, material use controls, spill prevention and cleanup, street and storm drain maintenance, and good housekeeping. Good housekeeping common problems are included around the trash containers and storage areas. BMPs must ensure that the waste, garbage, and floatable debris are not discharged into receiving waters. Prior to the commencement of earth disturbing or pollutant generating activity, the permittee must ensure that personnel understand the requirements of the permit and document that training. And lastly, preventative maintenance. Preventative maintenance program, which includes routine inspections and maintenance of existing BMPs, is a must-have for any project. Let's talk a little bit about structural BMPs. Structural BMPs refer to a physical structure designed to remove pollutants from stormwater runoff, reduce downstream erosion, and provide flood control. They also promote groundwater recharge. Structural BMPs typically require engineering design and engineering construction. Some structural BMPs provide considerable stormwater quantity and handling capability through the use of infiltration or detention. Others provide types of pollutant removal mechanisms such as sedimentation and filtration. Some BMPs provide a high level of both stormwater quantity handling and pollutant removal ability. In addition, structural BMPs can be divided into those that help reduce the pollutants or quantity of stormwater entering the collection system. Some typical examples of structural BMPs include sand filters, bioretention, stormwater wetlands, detention basins, infiltration devices, and rooftop management systems. Map and erosion control plan. In the previous slide, we mentioned to take your erosion control plan with you during inspection and update it as needed. The erosion control plan should reflect the observed BMPs in place at the site at the time of inspection. It's helpful to number the site BMPs on the erosion control plan to correspond with the site inspection report. If it's found that the ECP requires updating to add a BMP, for example, simply draw the addition in and date it. The city inspector will periodically check the site erosion control plan to confirm the erosion control plan accurately reflects the BMPs that are installed on site. Here is the BMP section of the site inspection report. This section is where BMP condition and effectiveness are documented. In the far left column, note how the BMPs are numbered. It's helpful for these numbers to correspond with the BMPs listed on the erosion control plan. Let's walk through an example of completing this section of the site inspection report. On line 1, we have silt fence, fiber rolls, berms, and wattles. You'll note whether the BMP is installed and operating properly, if corrective action is required, the date in which any maintenance or corrective action was first identified, and what you did. Here, we say we need to install sediment controls at the foot of the slope on the southeast corner. Going on to your next BMP, you just continue to identify if the BMP is installed properly, corrective action is required. Also, make sure and put your notes, even if you have a situation where it is not applicable. For example, on number 5, 6, and 7, these BMPs are not applicable to our site, so we simply wrote NA. The permit does differentiate between conditions requiring repairs and maintenance, and those requiring corrective action. The permit requires maintenance in order to keep controls in an effective operating condition and requires repairs if controls are not operating as intended. Corrective actions are triggered only for specific, more serious conditions. Whether a required stormwater control was never installed or was installed incorrectly, or it was not installed in accordance with BMPs requiring maintenance examples. These are things that you might see out in the field while you're conducting your site inspection report. Here's an example of a construction entrance requiring maintenance. Here, if you were completing your site inspection report and you were asked the prompt, is the BMP installed and operating properly? Here you can see it is installed, but not exactly operating properly. This one would require maintenance, possibly some freshening up of the gravel and sweeping of the street. Pictured here is some inlet protection that requires some maintenance. In the bottom left, you'll see some silt fence that has fallen down. And often what we find out in the field is silt fence is not trenched in correctly. Pictured here is some gravel or sandbags that require maintenance. Here again, we have a silt fence that has fallen down and sand has went down the slope and discharged onto the street. Here is a concrete washout area. Obviously, it's a little bit full. It's greater than that 75% holding capacity. So this will require maintenance and clean out. And lastly, here's a photo of some inlet protection that has some grass growing out of it. Obviously, the sediment is high enough to where the grass can actually reach the top of the grate. So this will require clean out as well. Now let's go through some examples of BMPs not requiring maintenance. Pictured here are some gravel bags around an inlet. The gravel bags are all in place, not allowing sediment to discharge into the inlet structure and are operating as intended. Second picture, we have some straw curlex that has been laid out for temporary stabilization measures, some wattle that has been added to the edge of a stream, protecting it from sediment. The third picture, the farthest on the right, is a good example of curb, silt fencing, and curlex protection, preventing the sediment from discharging to the roadway. In the bottom left, you have inlet protection. In the center, you have silt fencing. And a good example of a concrete washout. This one is rather large, but it has plenty of room for the concrete trucks to wash out without it overflowing. BMP key points. Site inspections will verify that all BMPs are implemented, maintained, and effectively operating to minimize erosion, control sediment, and prevent stormwater contamination to the MS4 or the surrounding water bodies. Note that the permittee shall maintain records of inspections and repairs for a period of at least 3 years after the project is complete and the permit is terminated. Step 4, pollution prevention and waste management. Of the site inspection report, the site inspector will provide responses and possible corrective action descriptions to the pollution prevention and waste management prompt in the far left column. Let's walk through an example. Is the site free of floatables, litter, and construction debris? No. The action needed here would be to pick up trash throughout the project area. Are material storage handling areas, including filling areas, free of spills and leaks? The response here is yes. If the response is yes, there's no need to document anything in the actions needed column. Are dumpsters and waste receptacles covered when not in use? The response here is no. If it's no, we're going to provide a reason. The reason here is a cover was not provided. So the corrective action is to use a tarp when the receptacle is not in use. Has preventative maintenance been conducted on equipment and machinery? Here we say NA because preventative maintenance is not being conducted on machinery and equipment at this site. Good housekeeping, pollution prevention, and waste management practices, as addressed in this section of the report, is pertinent for each project to maintain stormwater quality permit compliance. Examples. These photos are examples from job sites where pollution prevention measures have been installed properly, improperly, and some that are absent. You want to ensure that all concrete washout is caught in proper containment. Concrete washout is more than just water, rock, and sand. It contains other additives that can shift the overall pH of the mixture to be caustic and can pollute the environment. Ensure that your portable toilets are properly staked, are in position away from storm inlets and high flow areas, and make sure that your trash receptacles are being covered and emptied regularly. Pollution prevention and waste management key points. Ensure all chemicals are properly stored in containment or under cover in appropriately labeled containers and that their SDS documents are available for review upon request. Cover all trash receptacles when they are not in use and empty them regularly. Ensure all concrete washout is directed to a leak-proof container or pit. Ensure that portable toilets are properly anchored away from stormwater inlets and other high-flow areas. Spill kits should also be available in areas where spills or leaks are likely to occur. And remember, the permit holder is responsible for all releases of non-stored water discharges from the job site. So, good housekeeping practices are good pollution prevention practices. 5. Description of discharges. Discharge of stormwater associated with construction activity as defined in the OKR10 permit refers to a discharge of pollutants and stormwater runoff from areas where soil disturbing activities, construction material and equipment storage maintenance, equipment maintenance, and any other stormwater activity directly related to the construction process are located. The description of discharge section of the site inspection report. This section is to be completed if a discharge is occurring from the site at the time of inspection. Let's walk through this example. The first prompt says, was stormwater discharge or other discharge occurring from any part of your site at the time of inspection? If the answer is yes, provide the following information for each point of discharge. In our example here, the answer is yes. In number 1, it says specify the discharge location. For this example, it was the southeast corner of the project. Over in the next section, the observations say describe the color of the discharge. Here, we indicated that it was dirty and muddy looking, slightly red in color, but it didn't have any foam, odor, or sheen. If you describe yes, specify the location where the conditions were found and indicate whether modification, maintenance, or corrective action is needed to resolve the issue. Here, in this example, we indicated that we need to install an sediment control on the southeast corner of the project. Now let's go through some examples of discharges that may occur at your site. Pictured here are examples of sediment discharge off the site into the MS4. The OKR10 describes discharges of pollutants and stormwater runoff from areas where soil disturbing activities, construction material, or equipment storage are located. Any discharges occurring from your site at the time of inspection will need to be noted in the description of discharges section on your site inspection report. Is a common form of discharge related to construction activity. Per the OKR10, you're prohibited from discharging groundwater or accumulated stormwater that is removed from excavations, trenches, foundations, vaults, or other similar points of accumulation associated with construction activity. These waters must first be effectively managed by an appropriate control. Examples of appropriate controls include, but are not limited to, sediment basins, sediment traps, sediment socks, dewatering tanks, tube settlers, weir tanks, and other filtration systems such as a sand filter, a sediment bag, some form of passive treatment system that is designed to remove sediment. Appropriate controls to use downstream of dewatering controls to minimize erosion include, but again are not limited to, vegetated buffers, check dams, and riprap. One of the most common BMPs used for dewatering is the sediment filter bag. These bags should be located on a flat, stabilized, erosion-resistant surface, such as a well-vegetated grassy area, clean stone, or some form of geotextile fabric. You don't want to place the control on sharp surfaces that may puncture the bag. Do not place the control on steep slopes or within 50 feet of a receiving water body, storm drain inlet, or any form of natural site drainage feature. Description of discharges key points. The visual quality of the discharge, including color, odor, floating, settled, or suspended solids, foam, oil sheen, are all indicators of stormwater pollutants. If these pollutant characteristics are visible in construction site discharge, the pollutants may discharge into receiving waters or in other construction or natural site drainage features, such as the MS4. The purpose of the site inspection report, stormwater quality permit requirements, and BMPs is to ensure that the discharge from construction site is free from pollutants upon entering the drainage system. Certification of the site inspection report. Here, the site personnel, the person conducting the inspection, will basically sign, date, print, and add their title to the certification statement. The certification statement basically just says that under the penalty of law, that the documents and the attachments were prepared under the direction of a qualified person and are true and accurate. Remember, if you don't sign these certifications and document your site inspections, they didn't happen. Corrective action report. As we briefly discussed back in step 3, the BMP section, a corrective action report is completed when a required control was never installed or was installed incorrectly, a control is not effective enough, a prohibited discharge has or is occurring, regulators may require corrective action as a result of a permit violation found during an inspection. Here is the corrective action form. The form is completed when corrective action is triggered at your site. Typically, discovery of a corrective action is found during the course of a site inspection. Remember, routine maintenance and repairs are generally not considered to be a condition triggering a corrective action report. Let's walk through an example. In the top right-hand corner, you would put your DEQ permit number, the name of the project, the date the problem was first discovered, and the time, name and contact information for the person conducting the inspection or form, what site condition triggered the requirement to conduct the corrective action. In this example, it was a required stormwater control was never installed or was installed correctly or not in accordance with the permit. Provide a description of the problem. In this example, a silt fence was not installed as per the erosion control plan. Make sure to complete the deadline for completing the corrective action, which is typically no more than 7 calendar days after the date you discovered the problem. The corrective action form is corrective action progress. You will note why the problem occurred, the cause of the problem. In our example here, the sediment control was not installed as per the erosion control plan. You will answer how it was determined and the date of determining the cause. We found this situation during a site inspection on 1/1/2024. In section B2, stormwater control modifications to be implemented to correct the problem. In number 1, we list the stormwater control modifications that are needed to correct the problem that we identified. In this example, it's going to be to install the sediment control as per the erosion control plan. The date of completion is to be 7 days from our original finding, and there would be no update needed to the SWIP. Is the certification and signature. Basically, in this section, the person who completes the corrective action report will sign, date, print their name, and add their title. This is the same type of certification as on the site inspection report. It's basically certifying that under penalty of law that the document and the attachment were prepared by a qualified person and are true and accurate. Or key points. Know when it is required to complete a corrective action report. Install or modify the control and make it operational no later than 7 calendar days from the time of discovery. If it's infeasible to complete the installation or repair within that 7 calendar day time frame, document in your records why it's infeasible to do so. Remember to document your schedule for installing the stormwater controls and making them operational. This is our webinar for today. On this slide, you'll see some contact information for all of our environmental technicians, construction site inspectors, and our main office line. Thank you all for attending today's webinar. At this time, if you have questions, feel free to type them into chat or ask them here.
What a wonderful presentation. You guys did fantastic. It's no surprise, honestly, but I do always enjoy hearing folks do a good job, and you did. I didn't see any questions in chat, but if anyone wants to ask any questions, please feel free to do so now. I did go ahead and post my email address into chat. If anyone wants to request a certificate of attendance for today's presentation, please do send me an email. Don't request those in chat because we may not have your email address linked to your username on Teams. I will hopefully be able to get those certificates out this week, but if not, it'll be just as quick as I can. I've also posted the link for a recording of today's presentation. It should be available in the next week or so. So if you guys missed part of it or want to rewatch any of that, feel free to click on that link. And again, it should be posted up there in the next week or so. So I will stay on here and keep watching for questions. If Melanie and Jairus would also stay on, I'd appreciate that. But thank you all for attending today's session. We hope everyone enjoyed the presentation and continues to enjoy our webinar series and learn something new. We hope to see you again in June for the next installment, and I hope everyone has a great afternoon. With that, I will stop the recording, and again, we'll just hang out here for just a couple minutes if anyone has any questions.